So good morning, everyone. My name is Steve Moruzzi. I'm the National Training Manager for Laars Heating Systems. This live presentation is also being recorded. We're going to cover the Mascot FT. We're going to go through some product overview of the boiler itself, programming, combustion setup, burner removal, basic primary secondary piping, and outdoor reset. If you have any questions, please click chat on the upper left portion of your screen and you can type in some questions. So the Mascot FT is a condensing high efficiency fire tube boiler. It's available in both heating and combination boilers. Now, M stands for Mascot, FT stands for fire tube. HW would be heating only wall mount. CW would be a combi wall mount, and CF would be a combi floor mount. So we currently have three sizes. We recently discontinued the 80,000 BTU heat only model. We still have some in inventory. We're obviously going to honor any warranties with that. We will support those with parts as well. There is a 5-year warranty on parts for all of these products. An example of that, the 100,000 BTU boiler, those components are going to be the same in the 80. So currently we have discontinued that. So heating only models are 100,000, 140, and 199. Combination models, so combi would be wall hung. In this example, we have a built-in indirect that we'll talk a lot about. And then we also have the combi floor mount. Now, all of these are going to be a 5-to-1 turn down ratio on your modulation, other than the 199. The 199 is a 10-to-1 turn down. So an example of that, 199,000, it'll modulate all the way down to 19,900 BTUs. Up to 95% efficient, we'll go over outdoor reset and how your efficiency values change as your return water temperature becomes cooler. We get higher efficiencies that way. We can cascade up to 20 heating only models. Okay, so 20 boilers can be cascaded on the heating only models. We have ASME H stamping right on the nameplate. We removed the cover here. This is a 140 combi. We have a built-in gas leak detector right on the circuit board. So here's our circuit board, gas leak detector. So if we ever had a gas leak in the cabinet, that would fault, give you an error code right on the display that could be reset. Obviously, you'd have to check for a gas leak prior to resetting. We have a built-in low water cutoff. So right here on the heat exchanger, you'll see a red wire, and that is a built-in low water cutoff. A lot of inspectors want low water cutoffs out in the system. Again, state code will dictate that, but we have one built right in the cabinet in the top portion of the primary heat exchanger. That is an auto reset. So if somebody installs the boiler and didn't fill it or purge the air, your error code would appear on the display, but once you purge the air out of it, it automatically resets. It's not a manual reset. Very simple propane conversion. All of these boilers are going to ship natural gas, and we'll give you a propane orifice in the box. This is probably the simplest product to convert to propane to market. Up here, this is a 140. This is the air fuel mixing station prior to the suction side of the blower. And in behind this brass fitting is an orifice. So you would remove this fitting, pull the orifice out, put a new one in, and then we'll talk about dip switches. You just throw the dip switch to propane, and that's it. So this boiler can be converted to propane in less than 4 minutes. Very simple. We have a built-in primary pump. So when we talk about primary, secondary, and a boiler pump, that's built right in the cabinet. We also have inlet domestic and hydronic screens. So on the heat only, you're only going to have a hydronic screen. But on the domestic side, you'll have a domestic strainer as well for the combi boilers. And those are held in the bottom part of the cabinet. A little cotter pin, you remove the cotter pin, pull the strainer out, and you can clean it. Now also, while we're here, I want to talk about a condensate trap. We have a built-in condensate trap right in the cabinet. And that's a clear trap. And what I'm getting at is anybody doing any service or you go back to do maintenance on a product, that should be one of the first things service technicians are looking at. I don't care whose product it is. If it's a clear condensate trap or you have a neutralizer out in the system, you should be looking at that. Why? Because if that's dirty, where's that coming from? It's coming from the heat exchanger. It's an immediate indication that you may want to open up that chamber and clean it if needed. Now, a little bit about the heat exchanger. This is all stainless steel welded 3/16 stainless steel heat exchanger, and it's a fire tube design. So we have a burner up top, firing and heated flue gases travel down these tubes, down to a flue collector on the bottom, and then up and out your vent. Now, these tubes are sleeved with an aluminum coated. Why aluminum? Because aluminum transfers heat 5 times faster than stainless. So as the heated flue gases are traveling down these tubes, we're absorbing that BTU and transferring it right to the stainless. That is in your flue passage. And why I bring that up is some manufacturers that have cast aluminum heat exchangers, you have to add inhibitors to the heating system. If you don't, you can destroy the heat exchanger. There is no water on the hydronic side passing through these flues. This is strictly flue gas traveling down and then out in your flue collector and out your vent. Now, on the Combi boiler, and we're showing this is for a wall hung, we have an on-demand shell and tube design heat exchanger. Again, this is only on the Combi models. It's all stainless steel welded. There's no gaskets, and there's a double row of tubes. Now, most people are familiar with an indirect tank where you have a vessel that holds potable water. And you'll take hydronic boiler water, example of that is 180 degrees, and send that through the coil, and then you're heating the potable water. This is a shell and tube design. What we have here is the vessel itself stores hydronic water. The domestic water travels through this double row of tubes. And this is a 3/4 inch corrugated tube. And again, there's a double row. So a little bit more about it. First of all, on the Combi models, 140,000 input, 133 output for the heating. On the domestic side, 3.2 GPM at a 77 degree rise. On the 199, got 199,000 input, 190 out, 4.8 GPM at a 77 degree rise. And why I highlighted this is a lot of contractors ask, what are the advantages of selling a 199 over a 140? Maybe they only need 120 or 140,000 BTUs for the heating. So I threw in a couple of bullet points here that I'd like to talk about. First of all, a 199 at the 77 degree rise, you get an additional 59,000 BTUs. And that provides 1.6 gallons per minute of hot water to the customer. So it's 4.8 versus 3.2. Also, on a 199, you get a 10-to-1 turn down. What that means is we can modulate lower on a 199 versus a 140. The 140 is only a 5-to-1 turn down. So example, we can modulate on a 199 all the way down to 19,900 BTUs. A 5-to-1 turn down on a 140 modulates down to 28,000 BTUs, which is still a great turn down. However, during your shoulder months, you may not need a lot of heat, and that you've got a larger modulation on the 199, so we get a larger turn down rather. So now the 199 also comes standard with an onboard single zone pump relay. So we talk about primary, secondary, especially if they're using zone valves, you're going to have a system pump. We give you those contacts right in on the terminal strip. So that's an addition to it. Now they don't have to buy an additional pump relay or what have you. So that's all added in. You get a larger domestic heat exchanger. So 2 times the storage. So roughly 1 gallon of storage versus a half a gallon. And we'll get into that in a minute. We'll talk a little more about that. And on a 199, the cabinet is slightly larger. So for service repairs, it gives you a little more room. Example of that, we're going to show how to pull the burner here today, which is the blower and burner plate. And on a 199, you can take that all out as a one piece. If it is one of the smaller sizes or a 140, That's a two-piece removal. You have to pull the blower first, then the burner arm. Now, also, any of these boilers can be turned down. What I mean by that, or derated. So you can drop this down to 50% on a 199, but when you do, you'll actually turn it back to a 5-to-1 turn down. So on 199,000, if you only need 120,000 at full load, let's say you've got 3 zones, let it do its job. Let it modulate down. It may never need to go to high fire. Maybe if it's a 0-degree day out and you've got all zones running, it might have to, but then it's going to modulate right back down. So that's the difference on the advantages of a 199 versus a 140. Now, I also want to talk a little more about the shell and tube design heat exchanger. We list this as time to fixtures, 20 to 30 seconds faster than a plate type. So a lot of manufacturers are using the plate type heat exchangers for domestic. And what happens here, example of that, you turn on a faucet or a shower valve, and the boiler has to have some type of flow switch or a flow device telling you that it's in domestic mode. So with a flow switch, it triggers it, tells the boiler that we need a domestic demand. Well, we don't light right away. You have to modulate up. It's called pre-purge. And most manufacturers are going to modulate to 80 or 100%. That's the fan speed. Why? Because you want to get rid of any residual flue gases before you fire the heater. Now, most manufacturers aren't going to light off at 80 or 100%. They're going to modulate back down to around 30%. Now they're going to light. And they're going to stay there at that 30% for 1 or 2 seconds. Why? Smooth light off. Now you release it and it'll modulate to high fire. All of that is time to the fixture. And especially if a contractor is putting in a whole new system. So you're pulling out a boiler and maybe they had a tank type water heater. Well, that tank type water heater had stored energy. What I mean by that is if you set it at 120, 125, or 130, it always has 125 or 130 hot water in the tank. As soon as you turn on a faucet, you're delivering that hot water. With a plate type, you're not. So you have a lot of customers complaining about, especially if they had a tank type water heater and now they go to a wall hung or a combi type boiler, it takes time to get that hot water to my fixture. With the shell and tube design, we're always in tank charge mode. Again, this vessel or the coils are surrounded by hydronic boiler water. So that's already hot water. And as soon as you turn on the faucet, especially on a 199, you have now a gallon of water to allow this boiler to now fire, go through its pre-purge, light off, and run smooth. So also, time to fixture, you can also talk about cold water sandwiching. What is that? You take a shower, running nice and hot, you step out, someone else goes to get in the shower, and you still have a little bit of stored energy in a plate type heat exchanger. You turn that faucet on, that second person goes in, turns it on, puts their hand in the shower, they feel hot water. They step in, all of a sudden it goes cold or lukewarm and then gets hot again. That's called cold water sandwiching. We do not have that with the shell and tube design. Also, shell and tube design is less susceptible to poor boiler or hydronic water quality. It's also less susceptible to poor domestic water quality. Why? Because these plates are real small and you can plug these up. With us, with this heat exchanger design, these are 3/4-inch corrugated tubes, so less likely to plug up. We're also thermostatically adjusted, so we have a built-in mixing valve right inside our boiler, and it's digitally activated, so you set it up digitally with the display. It's not like a shower valve that you have to get in with an Allen wrench and adjust that mix. You basically set it at 120, 125, 118, whatever you need, that will adjust internally. And stored hot water function is fully adjustable through the control. And we'll get into that in a minute. So again, it's all stainless steel welded, no gaskets. The shell and tube portion of the heat exchanger helps with air elimination. Why? Because we have a 1/2-inch high vent right on the top of the domestic heat exchanger. So any air would be removed right there. Tank charge mode provides immediate response. So again, that was time to the fixture of endless hot water. And again, storage function is fully adjustable. And what we're referring to is the hydronic boiler water in the vessel. So and that ranges from 140 to 167. Now, example of that, 158. Well, if we have 158 degree water now and they turn on a faucet, that doesn't mean you're going to get 158 degree water for the next three minutes or 4 minutes. We have a built-in mixing valve that would immediately start adjusting that. Okay. So if you've got it set for 120, it's only going to deliver 120. We have a differential range that they could get in and adjust. Example of that is from 9 to 36 degrees. And again, that is on the hydronic side. And this storage function can be turned off. So example, you have a customer that's going away for a long vacation. Maybe it's summer months and that boiler is going to keep firing, 3, 4, 5 times a day just to be in tank charge mode. You can get into the programming and very simply turn that feature off. Or maybe you have a customer that has a tank type water heater, might only be 12 months old, and now they want to upgrade their heating system, but eventually they want to go to a Combi boiler. But they don't want to take this brand new tank out that they just put in and throw it out or put it out on the curb for someone to pick up. You can shut this function off and still use a tank type water heater. 4, 3, 5 years later, that tank fails, and now they can go right to the domestic here. They can plumb it in the beginning and just ball valve it off, or plumb it at a later time, just shut that feature off. We have a series of dip switches here, and we'll talk about high fire and low fire, but example here, dip switch 4. Do you have a 2-inch vent you're using or a 3-inch vent? So the collars up top are for 3-inch vent, and you can reduce that to 2-inch if you've got a little short run. So dip switch 4, you would very simply put to the right-hand position for a 2-inch vent. Dip switch 5, natural gas or propane. Again, they all ship natural gas. And as you'll look, you'll see dip switch 5 in the left-hand position for natural gas. Propane, the orifice comes with the boiler. You install a new orifice and throw dip switch 5 to the right-hand position. That's it. Now you're converted to propane. However, keep in mind, you do have to do a combustion analysis on any manufacturer's product over 84%. Venting on this, vent material, I will talk about it later, but PVC, CPVC, or polypropylene right off the top. What's included? We also give you a condensate hose for condensate. I strongly suggest utilizing this hose. There is a vacuum breaker right on it, and if you decided not to use it and maybe plumb your condensate in PVC, make sure you have some type of vacuum breaker on it, such as put a T-fitting in and a little riser. That way you're not backing up the condensate and going off on an error code. The relief valves in the box on the wall hung, that gets installed right on the top of the boiler. Heating only, will show you where that location is. We also give you an O-ring gasket kit that ships with every boiler right inside the cabinet. Example of that, this little green gasket you'll see here, that is a gasket that would be used for propane conversion. And in behind the fitting here, that's where that gasket is. And so if you took the fitting off and dropped it and lost it, at least you would have another gasket there available. And that gasket kit is right here down in the lower right-hand corner. The other gaskets, all of these are quick release components. So if you had to replace a component and you tore a gasket or lost the gasket, dropped the gasket, we give you additional gaskets. So that's why they're there. We'll give you the 3-inch mesh screens. This is all included. 2 types of wall anchors, the wall mounting bracket. Again, we talk about a propane orifice shipped with every boiler, and an outdoor sensor. Why? Because Department of Energy, DOE, mandates that, especially in residential, you have to use outdoor reset. So we'll get into some of that. Next, I want to talk about is primary, secondary piping. This is just basic that I'm going to go through for you. Primary, secondary piping is 2 closely spaced T's. Okay. What enters a T must exit a T. So if I'm putting 12 GPM into a T, somehow 12's leaving. Either 6 and 6, or 4 out one side, 8 out the other, or maybe all 12's coming out one side. So what enters a T, exits a T, if it's sized properly. Those two closely spaced tees should be 12-inch separation or no more than 4 pipe diameter center to center. By doing this, we have no or minimal pressure drop here. Now, I'm also showing a boiler pump. So I'm going to refer to this as our primary. Here's our secondary. The boiler pump, keep in mind, on our FT is right inside the cabinet. So you don't have to add this to the system. However, you will need a system pump if you're doing zone valves, or zone pumping, you'll need your zone pumps. Next, we're going to show 1.25-inch manifold. We're also showing here in this example 3 3/4-inch zones. Why? Because a lot of these jobs are being utilized for baseboard heat. Older systems had baseboard heat and 3/4-inch pipe, so that's what this example is. Now, a 3/4-inch pipe can only carry 4 GPM. That's it. That's all you're going to get through a 3/4-inch pipe. Even if you put 2 pumps in series, what you're going to do is increase a head pressure, but you'll still only get 4 GPM. And that's important when I get to it. So I wanted to bring that up. In this example, if a boiler requires 12 GPM, the pump comes on, we're going to pull 12 GPM off the manifold and send 12 GPM right back to the manifold. So through the heat exchanger and back out. With one zone calling, 12 GPM to the manifold and 4 GPM travels down the manifold. Why only 4? Because a 3/4-inch pipe in this example can only carry 4 GPM. So it travels through the zone to the return manifold. Well, if I put 12 GPM into a T and I've only got 4 GPM going out to the zone, where's my other 8 GPM? It travels backwards through the 2 closely spaced T's because there's no pressure drop or minimal pressure drop here. And that meets up with the returning 4 GPM, and it guarantees the boiler its proper flow rate. That's why most manufacturers prefer primary, secondary, or hydraulic separation. With 2 zones calling, 8 GPM would travel down the manifold. Why? Because you get 4 for each zone. 8 returns, and in this example, 4 GPM will travel backwards, meeting up with the returning 8 GPM and guaranteeing the boiler its proper flow rate. If all 3 zones were calling, nothing travels through the 2 closely spaced T's. Now, at the end of a cycle, and right now I'm showing 3 zones calling. Now let's say we're down to 2. Now we're down to 1, and we've satisfied the home or the dwelling. What happens? Do we shut the pump off? No. There's something called pump post-purge. And all you're going to do is just rat race that water out of the heat exchanger for about a minute. That time's adjustable. Most manufacturers have a pump post-purge, and that's what it is. And it's just going to pull that heat out of the heat exchanger so you don't trip a high limit, especially if you had a water tube design heat exchanger. Our product that we're talking about today is a fire tube design. So that is what pump post-purge is. Now, here I'm showing, and I mentioned earlier that we can cascade up to 20 heating-only boilers. So very simply here, we've got 2 heating-only cascaded. We have a system loop, and here we're showing zone pumping, okay? 2 closely spaced T's. There's my primary, secondary. So here's our boiler loop as primary, okay? Now what I want to talk about is on a heating only, you can add an indirect tank, okay? Be it a single boiler or multiple, you can add an indirect tank. But that indirect tank should be piped off the primary loop, not the system loop or secondary loop. Why is that? Well, you're supposed to be utilizing outdoor reset. So example of that, if you had a 0-degree day and you needed 180 degrees to heat that space, okay, you're going to run at 180. What do we want through an indirect coil here? You want 180 degrees. But what happens if it's only 50 degrees outside? Your supply temperature to your system might only be 130, whatever you set it at. And now you'll take forever where you may not satisfy that indirect tank. So it should be piped off the primary loop. And what can happen here is we'll go to domestic priority, and this boiler will elevate for domestic priority. Okay. Now, you could also potentially tie it off as another zone, land that aquastat at the boiler. But what will happen is the whole system then goes right back to 180, and there goes your outdoor reset curve. So Primary, secondary piping, that's where you want your indirect tanks. Now we offer these manifolds, these accessories, and here are your part numbers. Here on the left-hand side is the heating only model. And I talked about 2 stub outs. Here's your stub outs for your indirect. They're capped, just uncap them. But this little port here that's for your relief valve for a heating only model. So primary, secondaries right here. You already got your 2 closely spaced T's, ball valve, you can purge your system. So these manifold accessories are all set for you if you care to purchase them, or you can just plumb in primary, secondary yourself. On the right-hand side is the Combi, okay? There is domestic taps here for your Combi boiler. So this is showing for your hydronic. So the 80,000 to 140,000 BTU input, system connection size is 1.25 inches. So this is all 1.25 inches. Your tappings for your indirect are 1 inch. On the 199 heating only, this primary, secondary is 1.5 inches, and your tappings for an indirect is 1.25 inches. And on the other sizes would be 1.25 inches, and obviously not available with an indirect tapping. So those accessories are available. Next we'll talk about is outdoor reset. Now, Department of Energy mandates residential boilers need to have an outdoor sensor. Example of this, someone's buying a condensing boiler and delivering 180. Are you condensing? No. Especially if you're only designed around a 20 or 30 degree delta T. In my example, if we're supplying 180 and we're designed around a 20 degree delta T, we're returning at 160 and you'll never condense. So outdoor reset allows you, especially during your shoulder months, as it warms up a little bit, you supply less temperature, and now you're returning back potentially at the condensing threshold. So we'll talk a little bit about that. So outdoor reset continuously adjusts the boiler's heating output to match outdoor temperature. So here we're showing basic inlet temperatures, outlet temperatures, and condensing mode. So here's our inlet water temperature back to the boiler. So example that I used, 180 supply and returning at 160. Over here is boiler efficiencies. We're showing efficiencies from 80 to 100%. ASHRAE handbook, which is what this chart is going to base this on 10% of excess air. What is that? That is your air and fuel mixture before firing. So I mentioned you a mixing station. That's where your propane or natural orifice would be. That's your air fuel mixture right there. So they base that at 10%. And at 10%, the dew point, that's your condensing dew point, they're going to tell you is 130 degrees. So if I'm supplying 180 out to a system and returning at 160, I'm in non-condensing mode. However, as it warms up outside, now if I'm supplying 140 to a system and returning back at 120, you'll see your efficiencies start to go up around 90%. Why? Because now you're in condensing mode. So that's important to understand. And I'm going to show a basic outdoor reset curve here. On this left-hand column, this is your supply temperature to a system. And in this example, I chose 0 degrees at 180 degrees. And again, you utilize this depending on your system. I'm talking about baseboard heat that you may need 180 on a 0 degree day, but maybe you've got hydro air. Hydro air maybe only needs 160 on a 0 degree day. And then you maybe have in-floor radiant. Your max temperature there might be 120 or 130. And you would adjust your curve. So in the example I used was 0 degrees will hit our high temperature. Also, in this example, it's 68 degrees. So if it's 68 degrees out, do we really need 180 degrees to heat that space? Absolutely not. And I chose a value of 120. And you can customize this. You know, Massachusetts may be 10 degrees above 0 is your design day. Well, at 10 degrees, maybe you want 180. Minneapolis might be -5 degrees. You want 180. But also look at that dwelling. Is it a new home with blown-in insulation, brand new windows, or is it a 1953 home with poor insulation and drafty windows? And if that's the case in Massachusetts market that I said at 10 degrees will achieve 180, no, maybe at 20 or 25 degrees of outdoor air, I want to achieve 180. So you customize these. Okay? So in my example, at 0 degrees of outdoor air, we'll come up, we'll deliver 180. However, as it starts to warm up, in this example, I'm choosing 57 degrees. At 57 degrees, if we come up and plot this chart, I'll deliver 130. Based on a 20-degree delta T, that means I'm returning at 110. If I've got a 30-degree delta T, I'm returning at 100 degrees, and I'm well into the 90% efficient. So that's important to understand. Now, also, the other thing I forgot to mention, this is not your warm weather shutdown. So your maximum outdoor temperature is the maximum for your heating curve. Warm weather shutdown, in this example, always keep it a couple of degrees above your high point, okay, or your maximum outdoor temperature. In that example, I might choose 70 degrees. So at 70 degrees or if it's 72 out, someone turns on a thermostat, the heat won't come on. If you have a combi boiler, absolutely it'll run for domestic, but your heating system will not. And keep in mind elderly people. Some elderly people at 70 degrees feel chilly. They want to take that chill out of the air. You might want to choose 74 or 75. Okay. If somebody wants to be very aggressive, maybe at 68 or 65 degrees of outdoor air, they want to be in a warm weather shutdown. So you customize this to your system. Next, we'll talk about is understanding programming. Now, this is a very simple display for this product. First of all, we also have a on-off rocker switch, power switch. You'll see in one of the videos, I'll use that to power the boiler on and off. In addition to that, so this is an appliance. That's a plug-in. You plug it into a wall, and then you'll have an on-off toggle switch. But you'll also have a power switch for the display, or display power switch is how it's phrased. And that also becomes your reset button. Example of that in Pennsylvania last summer, there was a customer that has a summer home. They ran out of propane and they could not get the boiler to fire for domestic hot water. And this becomes your reset button. So once the propane company came, filled up their tank, they couldn't reset it. Why? Because they kept toggling the on-off toggle switch. This is your reset button or power button for your display. Next is your mode button. In mode button, this is where the installer can get in and change his parameters and set up things like an outdoor reset curve. We have a central heat button. That's where you're just going to get in and make a very simple change to your central heat. And also on the combi boiler, we'll have a domestic hot water set point button. Okay? So that's where you can change your domestic hot water setting for your mixing valve. On the heat-only versions, you'll have a clock symbol here. Okay? But on the combi, it's a faucet. Now, lastly, there's a scroll and select. So example, if I want to change my domestic setting from 118 to 120, I would press the faucet symbol. That icon would appear on the display. I would turn my dial to make it read 120, and then press this dial, and it will store that setting. So here I'm going to go in and play the video for you for programming.
So the lower right-hand button is considered our central heat button. And again, this is a combination boiler with an indirect tank. The top right-hand button is our domestic setting. The lower left button is our power button to the display. And the top left button is our mode button. The first thing I want to do is remove one of the outdoor sensor wires. And the reason that is if we get into setup for central heat, very simply by pressing that symbol, it's showing the defaulted setting of 120 degrees. Well, with the outdoor sensor hooked up, we cannot adjust that set point. So I'm going to power off the display, and I will remove one wire from our outdoor sensor. I'm going to remove the plastic cover here by pulling forward and dropping it down. Now with the sensor removed, I can repower up the display. It's going to go through its synchronization process, and we'll wait till it gets to the home screen. Now from the home screen, you'll see our setting right now. This is our water temperature in the boiler, is reading roughly 80 to 82 degrees. We have our outdoor symbol for our outdoor sensor blinking. That's telling us we do not have an outdoor sensor installed. Now we can get in to set up central heat. The thermometer symbol, right here, the lower right button, press that once, and it'll show our defaulted setting of 120 degrees for central heat. You can adjust this to your system, so if you have in-floor radiant, maybe you only want 120 or 130. Hydro air, you may want 160, or baseboard heat on the coldest day of the year, you may want 180. So for this example, I'll set it up for 180 degrees by adjusting the dial. Once I get to 180, press the select button once, it stored it, and now I'm back to my home screen. Next thing we're going to do is set up our domestic hot water. Now please keep in mind that the domestic hot water is defaulted for 125 degrees. You can adjust that temperature to 120 or up to maybe 125. However, you don't want to get into adjusting this temperature too high and putting somebody in a scald condition such as 130 or 135 degrees. So I will explain that in a second. Very first thing we're going to do is the top right button, the faucet symbol. Press that button once, and there is our defaulted setting of 125 degrees. You can adjust that down by scrolling down to 120, setting it, or in this example, I'll say 116. Press select, and now I've stored 116. To go back and double check it, we hit the faucet symbol. If you now don't have enough hot water, now once we're in the mode, you can readjust it, but we'll only get to 120 degrees. To get around that, if you need to go a little higher, such as 125 or 126, start from the home screen, press the faucet symbol once. With our faucet symbol now appeared on the lower left corner, press and hold that symbol one more time. Now that'll allow us to come in and adjust the domestic temperature high. In this example, I'll bring it back to 125. Now that I'm there, I can press the select button, and now that will store it.
Now I'm going to pause the video here. This high setting can go as high as 140. We didn't advertise that on the video. These videos are on Laars.com and YouTube. In addition to this, also under document downloads, we have startup guides that'll walk you through all of this picture by picture. But so that high setting on the domestic, you can take it as high as 140. But keep in mind, scald factor. Now, also, some states do require external mixing valves on the domestic side. And if you have an external mix and you want that set maybe at 120, you want to come in and elevate your internal set point, because we also have a mixing valve. You don't want them both set at the same temperature. You want your internal one running a little higher, so maybe 125, 130, or 135 in that example. So again, that can come as high as 140.
I'll double check it by pressing the domestic button. Okay, so now that we've set our central heat set point and our domestic set point, we need to get into the installer parameters and adjust our outdoor reset curve. They're already defaulted, so you can customize that to your region. So, very first thing I'm going to do is press the power button and turn the display off. Now I'm going to press and hold the mode button and wait for the screen to liven up. So now 1EH has appeared. I know we're in the installer parameters. The very first thing I want to do is scroll to 6OH. That stands for the outdoor high temperature. All of this information is in the manual and the startup guides. Now with my outdoor high, or 6OH, press the select button, and now I can adjust that. So in this case, I'm going to use 68 degrees as my example. Adjust it to 68, press select, and I've now stored my outdoor high. I'll explain the outdoor reset curve in a minute. Now that I'm back to the screen where it says 6OH, turn it once. 7OL, that stands for the outdoor air temperature low. So I press select, and in this case, I'm going to adjust that to 10 degrees of outdoor air. Now that I'm at 10 degrees, I'm going to press the select button again, and we'll store that. Now what I want to do is I want to scroll to 15 OF, and that is the off point. That is our warm weather shutdown. press select, it's defaulted for 100 degrees. In this example, I'm going to turn it down. I'm going to turn it down to 70 degrees of outdoor air. So at 70 degrees of outdoor air, if somebody turns on a thermostat, the heat will not come on. I've adjusted it down to 70, press select, and now it'll store it. Next, I want to turn the scroll button to 16CH. That is our central heat high. Okay, it should be defaulted, so 16CH. Press the select button. It should be defaulted for 180. However, if you've got radiant, in-floor radiant, and you don't want that temperature to ever go above, example 130, very simply turn that down. This is for the central heat only. Make that adjustment, press the select button, and it will store it. For our example, I'm going to bring...
So I'm going to stop the video here. So in that example, in-floor radiant, and I mentioned you want to bring this down to 130 or whatever your high temperature is that you want. Keep in mind, if a customer feels cold and they read a manual, they can come in, press this button, and then jack that from 130 back to 180. By doing this here at 16CH, it limits them as high as they, that example would be 130. So if you're in-floor radiant, drop that value down. In that example, you don't want 180 degrees going through PEX tubing. So keep that in mind.
Get back to the 180, click OK. And next, I'm going to scroll to 17CL. That's our central heat low temperature. Okay. I will adjust that to 120 degrees. Okay, very simply by using the scroll button. Adjust that to 120 and press OK. Okay, so now that we've got our central heat set point set, the domestic hot water, and an outdoor reset curve, what we're going to do is power off the boiler, reinstall the outdoor sensor, and then you can power the boiler back up and operate the boiler.
So with that, I'm going to move forward to the next section. So that's the programming. And again, we have videos online. We also have startup guides, and all of this information is also in the installation and operation manuals. Next, we'll talk about combustion setup. Every manufacturer to market, over 84%, requires a combustion analysis. We see a lot of, contractors that don't own analyzers. You really should. And especially if you're doing any type of preventive maintenance, it's great revenue for you. You can tell your customer you're going to come in annually, not only go through the equipment, but you do a combustion analysis and make sure it's running at peak performance or what have you. But you need a combustion analysis done. So we're going to talk about that next. On the dip switches. So here's our circuit board, dip switch 6 and 7. This is where you're going to lock a boiler into high fire or low fire. Dip switch 6 is your high fire. So example, I would throw dip switch 6 to the on position, and that boiler will modulate right up. You can actually look in the sight window and you'll see your flame pattern modulate up. You're going to check your analyzer up here. You're going to take the plug out, put your analyzer in. You'll see this video in a minute. Check your CO2s. We'll show you those values. And then go to low fire. Adjustments are only made in low fire here. So I do show you an example of that. So next would be throw dip switch 6 back to the normal position or the right-hand position. Dip switch 7 to the on position. You'll see your flame pattern in your sight window modulate right down. With your analyzer, check low fire as well. So we'll go in and play the video for you now.
First thing we're going to do is remove the cover. There are 4 screws, 2 on the top, 2 on the bottom. I've already removed those for the demonstration, so I'm simply going to lift the cover out of position. All right, so the next thing we want to do is disconnect the outdoor sensor wire. And the reason is, obviously, for example, like today, it's above 70 degrees and I'm above my warm weather shutdown, so even giving the boiler call for heat will not allow it to operate. So we can get in and do combustion setup. So very simply, I'm going to power the boiler off. I'm going to disconnect one of the outdoor reset wires. To remove the outdoor wire, we have a plastic cover. Simply pull forward. I'm going to slide that down and remove one of the outdoor reset wires. With that disconnected, I'm going to power the display back up, or the boiler back up, and we'll go through a sequence. Now we're registering 87 degrees. That's the tank temperature, or the heat exchanger temperature. We haven't been running this very long. Outdoor sensor's disconnected, and the outdoor sensor symbol is flashing. That means that that sensor is disconnected. I'm going to give the boiler a call for heat. All right, so now you can see a flame signal appeared on the screen in a radiator symbol. That tells me we're in central heat mode and we have a flame signal. You can look in your sight window and you'll actually see the flame appear. The very first thing we want to do is set up a combustion analyzer. I'm going to remove the plug from the vent terminal and install the combustion analyzer. Now with my analyzer installed, I want to lock the boiler into high fire. So here we have natural gas, which is dip switch 5, which is on the left-hand position or the on position. We have a 3-inch vent, which is dip switch 4, which should be the left position, which is the on position. To lock the boiler into high fire, dip switch 6, simply push that to the left-hand side to the on position, which will now lock our boiler into high fire. Be patient with your analyzers. Some analyzers can take up to 90 seconds to start adjusting. Be very patient with your analyzer. We force the boiler into high fire. So what we're looking for, our range for high fire or maximum fire is 8.5 to 10.5% CO2.
Now, I just mentioned to you 8.5 to 10.5 CO2. Some manufacturers, most manufacturers go by CO2. There are a couple out there that go by O2. So make sure you read your manufacturer's instructions, okay? We go by CO2.
Looking at our analyzer, we can see we're well below that. So we need to make an adjustment. All adjustments on these are made in low fire. So what we have to do is put dip switch 6 back to the right-hand position or the off position. Dip switch 7, which is our minimum fire, turn that to the on position and let the boiler modulate down. Once we're in low fire, now we can readjust our low fire setting. So what we want to do is make a gas valve adjustment under this cap. So I'm going to remove the cap. It's a number 4 millimeter Allen key.
Now, early version, the cap was a 4 millimeter Allen key. The later versions are a Torx bit. And I believe that Torx bit is a number 20 Torx bit.
And now we can make an adjustment. And right on the valve, it's going to show you clockwise will increase, counterclockwise will decrease. Well, we know we had to make a clockwise or increase adjustment. So what I'm going to do is just take a very small adjustment. So we made our low fire adjustment. What we want to do is be very patient with your analyzer. Make sure we're within range for low fire. As the chart will show you, min fire or low fire, that range is between 8 and 10% for natural gas. So as you can see, we're slightly below 10%, which is good. We're within range. We want to turn the boiler back to high fire. To do that, we go back to our dip switches. We turn dip switch 7 to the off position, which is the right-hand side. Dip switch 6 to the left-hand or on position, and allow that boiler to modulate to high fire. Once we've run in high fire, we wait and make sure we're within range. Okay, so now that we've checked our high fire, we're running around 92, 93% CO2. We'll go back in one more time and double check our low fire. I'm going to throw dip switch 6 to the right-hand position, dip switch 7 to the left-hand position. Be patient with your analyzer. Let that modulate down and double check your low fire adjustment. So now that we've checked, again, our high fire CO2 is around 9.4%. Low fire was running around 9%. We want to make sure that we go back in and put this back into normal operation. In this case, dip switch 6, because we're in high fire, goes back to the right-hand position or the off position.
Now, if you forget to put your dip switches back, that boiler will stay in that mode. So if dip switch 6 was on the on position, that's high fire. Every time it lit off, it would modulate right to high fire, and you would start short cycling your boiler. If you left dip switch 7 in the on position, that's low fire. You leave the job, well, I guarantee you, if it's cold days, within 24 hours, you're going to get a phone call that the boiler's running and they don't have enough heat in the space with the house. So make sure those dip switches are back in the off position when you're done. Lastly, you're going to go in and reinstall your outdoor sensor. And if you made any adjustments, such as a set point to raise that up to keep a boiler running long enough or longer for high fire operation, go back and readjust your settings. Next, I want to talk about is venting. And venting is a big concern out there for most manufacturers. This is just a screenshot of what's in the manual. And this is a side view for combustion air 90 and exhaust. This is a front view or face on. First of all, your combustion air should always be lower than your exhaust, okay? And this is a 90. And you would never, ever put a 90 on your exhaust, forcing those flue gases down. What happens is flue gases come down and they'll get drawn right back in again. Cross-contamination, it's flue gas recirculation, plays havoc on everybody's heat exchanger, burner, ignition point, etc. And there's quite a bit of cross-contamination out there in the market. And again, it's every manufacturer. So it's really important to read their instructions. And we can be in two different pressure zones. What I mean by that is we can take combustion air from the space, such as a basement, and just vent outside. Or we can bring combustion air from a sidewall and vent through the roof. Or the east wall, bring combustion air, west wall, exhaust. So we can be unbalanced, okay, in two different pressure zones. Again, you can go 100-foot exhaust and 100-foot combustion air in 3-inch vents. So again, 100 of each. So what we're talking about here is a minimum of a 12-inch separation. I always like to see my exhaust up higher. But on sidewall venting, where we're coming out like this, they're telling you that your exhaust pipe should be at least 12-inch away or 12-inch off the dwelling. Not only 12-inch separation, but 12 inches off the dwelling. And how many neighborhoods have you driven past and you see them both come out at the same elevation, and your exhaust pipe is right here? Flue gas recirculation can take place. All right. So hypothetically, if you want to come out and snorkel up, you can. So here's our combustion air intake. Suggestion is snorkel up minimum of 12 inches. All right. And then straight out, not back down. Especially, again, flue gases are just going to recirculate. So on your snorkel, or, again, you want to be 12-inch horizontal and minimum of 12-inch vertical. Okay. However, if you're in climate, you've got a lot of snow, maybe you're coming out a sill and you want to get above snow level, which you're supposed to consider, and get that above snow level. You can also gooseneck both the combustion air and exhaust up, okay? So again, minimum of 12-inch horizontal, minimum of 12-inch vertical. Now, the National Fuel Code, NFPA 54, a lot of people try and go by line item J, clearance to non-mechanical air supply, inlet to a building, or combustion air inlet to another appliance. However, that's non-mechanical, okay? And it talks about 12 inches. If you've got multiple pieces of equipment, your clearance to a mechanical air inlet supply should be 3 feet. And what I've done here, this drawing actually came out of our Neotherm manual. And this is, if you've got multiple appliances, again, your separation here for your exhaust to combustion air should be a minimum of 3 feet. 12-inch above for your exhaust. Again, this is combustion air, so this is 90 down, and that example, you might be 15 inches or 17 inches before you start to recirculate. Keep in mind, snow grade, snow level, okay? So multiple units should be 3 feet apart, not only 12 inches apart. And what we're showing here is the concentric kit. This is more of the bazooka style, which is fine. We're certified for that. We're also certified for the flush mount kit. But also read that manufacturer's instructions. Example of that, how many times have you gone into or driven past a home and you'll see these sticking off the dwelling 8, 10, 14 inches out? That instruction sheet tells you 1 inch off the dwelling, because having your vent cap out here, so there's your exhaust, here's your combustion air, having it out here, you can get flue gas recirculation, especially in low fire. You're not forcing those flue gases 3 feet away from the vent. They're trickling out right here, a little wind, they get drawn right back in. In multiple units should have the distance of 36 inches, 3 feet apart. So you do not get flue gas recirculation. Next, every manufacturer out there is running into PVC shavings in their burners, their blowers, what have you. Where's it coming from? During the installation, a lot of installers are using Sawzalls to cut your PVC pipe or CPVC pipe or whatever you utilize. And they're not wiping those shavings down. So where does that end up? Once the blower for the appliance comes on, they get sucked right into the blower and then spit into the burner. And in some cases, you can turn the blower or turn the appliance on, and all of a sudden you hear them just, mixing around inside that blower cage. Okay. Good practice. Wipe those down because they can end up in your burner. So with that, one of the reps had asked that we show how to remove the burner. This is a 199 that I'm going to show you next.
Hi, my name is Steve Moruzzi. We're here with Ken Resnick. This video is intended to show how to remove the blower and burner on the Mascot FT. You will need to isolate the gas, shut off gas to the boiler, remove electricity for this repair. We've already removed the 2 Phillips head screws on the top, 2 Phillips head screws on the bottom. We'll remove the cover.
Removal of the blower assembly requires removal of fresh air inlet boot. That's held on with a clamp. You can slide that clamp down the rubber boot and remove that boot and get it out of your way. Removal of the gas train is also necessary. And underneath that aluminum tubing of the gas train, you're going to find 2 cardboard gaskets. Orientation of those gaskets is not important. They can go either way. Replacement of those gaskets are necessary after inspection of them if you should see that they're cut or torn or spread. Furthermore, removal of the high limit for the burner assembly, 2 wires. The orientation of these wires is unimportant.
What we're showing here is the 140 burner plate that will come out. Currently, the boiler we're working on is a 199. However, there is a burner overheat sensor right here that does not have to come off. The 2 screws do not have to come out on the 199. On the smaller sizes, they do. Why? Because that comes right down through to the top plate. And if you take out all of the nuts to hold the burner in position, if you remove those nuts, you still also on the smaller size need to remove the 2 Phillips head screws for the burner limit.
Removal of the electrical connector for the blower motor. Also a lock, squeeze, pull down. And you can see the lock there on that Molex connector. And you can move that wiring out of your way. One of 2 tools necessary. One can be a small ratchet. What you're seeing there is a 1/4 inch ratchet with a Phillips head adapter on it, or a very small stubby Phillips head screwdriver. Loosening of the 4 screws that hold the blower plate down onto the boiler itself. 2 screws in the front, 2 screws in the back. Can be accessed either with that Phillips head screwdriver or the Phillips head attachment on the ratchet.
So Ken is removing on the 199 the blower and plate all is one. On the smaller size boilers, such as the 140, the headroom, you will not be able to get the blower and plate all out as one. So you will have to remove the blower from the arm, which entails, point out the 4 nuts.
Which entails now removal of the 4 10mm nuts, 2 up top and 2 on the bottom.
Then taking the blower out and then separately removing the arm. But in this example, this is a 199 combination. You'll pull all of it out in one piece.
All right, I'm pausing the video right here. On the 140, so we had talked about removing the 4 bolts to pull the blower from the burner arm, or from the neck to the burner arm. On the 140, there is a mesh screen in here, okay? So we've had some cases where dryer vents, so you're exhausting out the back of a house, or combustion air off the back of the house, right near a dryer vent, all that dryer lint is being sucked in. It will not only make it to the screen, but also potentially the burner. But on the 140, there is a screen right here. Why I stopped the video was I did explain that to a contractor one time, and they were looking for the screen down here. So that screen is right at the outlet of the blower, okay? So keep that in mind. And again, things like dryer lint is going to plug up anybody's burner. So during your installation, you really need to make sure you've got a good distance there as well, okay? So look at your overall vent system, okay?
During removal of the blower in one piece, you will notice that brass orifice. That is your gas orifice. That orifice can come out very easily. Be careful that it doesn't fall onto the floor. You do need that back in place during reassembly.
And again, this is a 199. It has a smaller orifice. The 140 and smaller boilers will have a threaded orifice into a plastic housing. Be careful that you don't break that if you're trying to tighten that. On the 140, you do not need to remove the orifice from the venturi. Now, I want to mention to you, a lot of times contractors are not cleaning their PVC shavings or PVC pipe when installing the combustion air intake. Where does that end up? Well, that comes down our combustion air boot through the blower and the top of the burner. Ken will pull the burner and then we'll get a look at that, but that will plug up your burner, and this is a good example.
Here you're seeing removal of the very large gasket that acts as the combustion gasket on the top of the burner assembly. Inspect that gasket, inspect it for cracks, crimps, flattening out. If need be, replace that gasket before reassembly.
And that gasket has to be in position correctly, or you could get potential gas leak in the cabinet.
Removal of the burner plate is best done with a small screwdriver. You'll notice that there is a notch in the very front of that burner plate. Insertion of the screwdriver into that notch, and you can lift the burner plate out of position from the top of the boiler. Here you're seeing those PVC shavings that Steve mentioned earlier.
So here are some that are not burnt off, and here are some that started to melt and burn off. And what happens is they will actually plug these orifice holes, and you won't get proper firing.
After visual inspection of the heat exchanger and cleaning if necessary, reassembly of that burner plate on top of the heat exchanger is now going to happen. Be careful and do not give in to the temptation to touch that ceramic glass portion of the burner plate. It is very, very fragile. Cleaning the top of the burner plate off as necessary and reinstallation. Burner plate sits down up on top of the heat exchanger, again assuring that that notch is facing forward. Installation of the gasket. After inspection of that gasket and replacement if necessary, make sure that gasket, as was said before, is in its proper place. And we can now go ahead and put the burner housing back together. Reversing our steps and reinstalling the burner housing itself, please keep in mind that orifice So I find it best to just hold the orifice in place while getting the housing back onto the top of the heat exchanger.
This is showing the 140 blower with the orifice on the 140. This threads into position, so you do not have to remove that for removal of the burner plate. However, if you are putting a new orifice in or checking it, just make sure it's snug. Don't tighten down too much or you'll crack the plastic venturi of your mixing station.
If you have any technical questions, please contact product support at 1-800-900-9276. Thank you. So this is an example of some of the videos we do. For those that aren't familiar with it, right on Laars.com, which takes you to the YouTube link as well. So we have a series of videos in even how to replace, remove and replace components, how to pull a condensate trap and clean it, how to replace the igniter, etc. So please make sure you're viewing those if needed. Again, we put those out there for you. Warranty for this product is 10-year heat exchanger and 5 years parts. And resources. So Laars.com. And again, we had talked about videos right here on Laars.com and YouTube. Laars Technical and Application Support, 1-800-900-WARM for warm. Technical support is prompt 41. Application support is prompt 72. And part support is prompt 71. Also, all of our documentation, I&O, installation operation manuals, startup guides, that's all under document downloads at Laars.com. Thank you.